Welcome to demo session 4 of the course FPGA based signal processing systems. In this demo, we will be simulating the course that were taught in the lectures on timing control. So we will deal with all the examples that were given in that lecture. The first one is this. The corresponding this lecture, the code is the first one code, this procedural assignments. The first is blocking. Yeah. So the first case is blocking, that is immediate assignment without any delays. So 0, 1, that is our input. Always at the rate of input, whenever input changes, 0, 1 will be assigned immediately, the value of input. And we will run this first and then it will be easier to describe. So executing. Yes. Then 0, 1, that is immediately it will be assigned. So here it is 0, 1, 0, 1, immediately assigned. Input change as at the same instant it got assigned here. And there's a glitch here, and this glitch also got assigned in this case of blocking immediate assignment without no delay. In case 2, that is always at the rate of input. 0, 2 is assigned the value input in. It's a non-blocking case that is late assignment, but there is no statement after, so there is no delay at all here. So here also output is the same, and the glitch, there is one glitch here. This glitch also got passed as soon as the input change occurred. It got assigned for the case of 0, 2 also in this case. Then there's a case of always at the rate of input. This delay hashtag 5, 0, 3 equal to input. Here it's a blocking statement, but the evaluation is delayed. So in this case, this delayed evaluation means here this output. It can be shown here. This is the output. It is the same output. It is the same output as this. So for this case 3 evaluation is delayed. So as explained in this slide, it is a slide from the lectures. Evaluation, input change occurred at this, but it is not evaluated. It got evaluated late and assigned late. And here input change occurred. By the time it got evaluated, the input change, it's a case of inertial delay, means that's why it got ignored. It couldn't evaluate this glitch. Means by the time evaluation is done, this signal was gone. Then it is next case is 4 hashtag 5, means after some delay 4 is assigned with a non-blocking statement equal to in. So non-blocking is the delayed evaluation again in this case, delayed evaluation. So here it is 4 delayed evaluation. So here is the delay, and here it's similar to the previous case. It's like an inertial delay only. So this glitch is not passed, and we got the output like this, as can be seen here in the slide also. For 4 here means it is evaluated. This is non-blocking statement is evaluated, but by this time input has changed, and so it doesn't reflect here. So by the time it is assigned, the signal was not there. So it is not showing here, means it is like inertial delay only. Then for case this 0, 5, it is here. Blocking hashtag 5, 0, 5 equal to hashtag 5 input blocking. That is the case of blocking statement and delayed assignment. So here assignment is delayed. So how it is? 5. Here this assignment is delayed. Again, it's a case of delayed statement, and actually here this glitch is evaluated. By the time it is assigned, this input has changed to 0. which couldn't get evaluated. So this is not reflecting in the output. Only in this part where the glitch was evaluated could be assigned. And when it was assigning, this input had changed, but it could not be evaluated. So that input is not showing. And then this part got evaluated and it is showing us this waveform. Means along with the glitch, it got almost clubbed together. And it's showing like this. As was explained in the slide also, it is like this. Then the final case, it is this 6. It's a non-blocking delayed assignment. And how it looks, here it is 6. It got evaluated, it is not assigned yet. So everything got evaluated, means the glitch, this high and the low, both are evaluated. They are not assigned. They are not assigned, but are evaluated. And after hashtag this time hashtag 5, it will be evaluated. So the glitch also got is obtained in the output. And this, of course, there is a late assignment with some delay. So there is a delay of 5 here. See, a delay of 5 everywhere. It is shifted by 5. 30, 35. It is 10, it is 15. So this was example 1. Now we will move on to the next example. Next example is, we'll open here, timing controls. Okay, this TICL2. TICL2 is the next example. Open here. Okay. Project timing controls open. Would you like to close it? Yes. Then timing and timing 1 TB. So it is the second example as in the lecture also. Here it is, this case. Sequential assignment, no delays, and it's here. Sequential assignment, no delays. It is in slide number 10 of the lectures. It makes a parallel flip-flop as shown here. It's a parallel flip-flop. Input to both and the same clock and delay and Y1, Y2. Input is assigned to Y1 and Y1 is assigned to Y2. So it is like this. We will run it first. Run it. Fit to the window. See the input. Clock cycle is this. Clock signal is this. Here's the input. But only at the positive edge of clock, it will execute this block. So when positive edge of clock came at this 10 nanosecond, it executed the blocks and found and made V1 equal to input. And these are blocking statements. Input is assigned to Y1 and then this Y1 is assigned to Y2. So both have the same value. So here it is. And only when the next clock cycle comes, it executes this block, begin and block, and makes both of them equal to 0, both Y1, Y2 equal to 0, because input at this clock high is equal to 0, so it becomes 0. And here, though input is present, but clock cycle is not there, means positive edge of clock is not there, so it remains 0 until the positive edge of clock comes, and then it evaluates and assigns Y1 and Y2 like this. So this was example number 2. Now we will move on to the next example. So it is in slide number 10 of the lecture on timing control. Now we will go to project, open the next project. TICL2, it is TICL3. Close it, yes. It's sequential assignment, no delays, delay is not there. And slide number 14, it forms, it is in slide number 14 of the lecture on timing control, and it forms a shift register with 0 delays. Okay, so always at the rate of positive, we will execute run the simulation first. Here, always at the rate of positive edge of clock, this beginning block will be executed. That is, input will be evaluated and y1 will be evaluated. But y1 is not assigned this current input yet. Okay, the present input is not assigned to y1 yet. So at this first positive edge of clock, this y2, this y1 is still the old value of y1. So this y2 also will not get the new current new value of y1 or a new value of input. So it will be like this. So when assignment happens at the y1 will show this current value of input, but y2 will still have the old value. Okay, and only when in the next clock cycle, it will read for the previous this value of y1 will come here, and then this value of y1 will come here. It is like this. It's due to this y1 not assigned not being assigned the current value of input here. So this delay is happening in y2. In the lecture, it is in slide number 14. As you can see the circuit for this. Slide number 14 is this. So on there's this delay. This y1 when comes only then this clock cycle, and at the next clock cycle this y1 is assigned to y2. It is like this. Now we'll move on to the next example, which is so it is example number 4. We will go to example number 4. Open TSCL4 example number 4. It is sequential assignments, delayed assignment, and delay though it will be delayed assignment because #5 this delay is here in assignment. So it is in this example is in slide number 16. Slide number 16. Here it is. This case, it forms this. There is a delay in this clock. It is equivalent to a delay in this clock, and this first one is equivalent to delay in this D flip flop. So #5 here, as you can see in the output here. This is a clock signal. It's a shift register with delayed clock on the second stage. Delayed clock on the second stage. So clock here, input is this, and y1 input is evaluated, assigned input is evaluated, and y1 is here. And at the positive edge of clock, after it gets assigned, when it gets assigned, it is equal to this. But this is like a delayed clock. So after 5, it gets the value of input. So it is high here. It is like this. So in the simulation also, it's the same waveform here. Here it is. Okay, it's like delayed clock, and here it is. Assignment is getting delayed due to this #5. This #5. So it is example number 4. Then we will move to it's a shift register. Delayed clock on second stage. Delayed clock on second stage. Delayed clock on second stage. Now we will move on to the next example. So we will move on to example number 5. Here, project. This example number 5. So here it is, we have covered up to 16. So it is this example. Can match if it is not. This timing.v. Yeah, it's the same example. In this example, begin this non-blocking statement is there. And this #5 input, #5 input, it's like delay in assignment. So here it is. Again, it's delay. This evaluation will also happen at the same time. So again, it is #5 here. So this here also delay is not in clock, but in this D flip flop. While in this case, due to this blocking statement, it was acting like a delay in the clock signal. Here, due to non-blocking statement, it is occurring like a delay in the D flip flop. So there is slight change in the output also accordingly. here, here. Instead of this and delay in the clock cycle, it is like delay in the buffer stage itself. So it is occurring only after this input, this y1 input is shifted, and then same here it is this y1 and then comes to y2. It's like the shift register with delays, this and delay. So in the simulation, we are here 18. In the simulation, we can show, we will run it, same waveform we can show. Here, fit it to the window, this. So yes, you can see that input is assigned this after hashtag 5, this 5 time units delay is there, and then y1, and then here again 5 time units delay for assigning this. So it comes here. Okay, this has clock is high here, and then 5 time units delay. So this input comes to this. Now this value, as you can see here, this y1 would come to y2 after hashtag 5. So here it is hashtag 5 means hashtag 5. This is the delay, and this input came here. It's a what? It's a shift register with delay. Okay. Now we will move on to the next example. Next example is this shift register with delayed clocks. Here it is. Here. This delay is in the clock itself. First clock is delayed by 5. First clock is, and it is delayed. It's delaying the execution of this. Okay, even in though it is blocking. So means blocking case, blocking assignment is here. Hashtag 5 means delay in the clock, and hashtag 5 means again a delay in the clock. But only after execution of this block will be only after assignment happens in this first statement. Then again after 5 time units delay, this evaluation assignment will take place. So it's for the second case, for y2, it is like delayed twice. Means clock is delayed by 5 units here, and then again by 5 units here. So for this it is 10 units delay. For this it is 5 units delay. So we will check this code here. TICL 6. That is open TICL 6. Yeah, it is. This is slide 22. Shift register with delayed clocks. Input is evaluated and assigned after this time unit hashtag 5. And no, input is evaluated, and then y1 is also evaluated, and during assignment is this hashtag 5 and hashtag 5 and delays. So for this it is like a clock delay of hashtag 5. For this it is like a clock delay. For this it is like a clock delay of hashtag 10. So we will run it. So equivalently, it is like for the first y1 is it's like the clock shifted by 5. It's like the clock shifted by 5 units, and this D flip-flop work. And for this case, for the y2, it is as if the clock shifted by 10 10 unit. Okay, so it is output is shifted like this. It is just as if it is responding to a clock shifted by 5 time units, and as if this D flip-flop is responding to a clock that shifted by 10 time units. So we are getting the same output here. It's a shift register with delayed clocks. Here it is. See, for is it the same code? Yeah, here it is. Now see, shift register with delays. This is the previous example of mistake. See, next example is TICL 7 actually. TICL 7. Here, TICL 7 is this. So, sequential assignment, delayed evaluation, shift register with delayed clocks. Here it is. Y1. These statements are is blocking, and still the execution is delayed, so evaluation is delayed. #5. This is what it forms, and this is the output, shift register with delayed clocks. Here it is. We run the simulation. Here, delayed clock. It is as if it is responding to a clock shifted by 5. Here it is as if it is responding to a clock shifted by 10, as can be seen here. It is as if it is responding to a clock shifted by 10. Now we will move on to the next example, that is TICL 8. Then TICL 8. Here it is. Sequential assignment, delayed evaluation. This evaluation is delayed, and it is after it is evaluated, it will in this block it will be one by one. It will be assigned. So we can simulate it. Clock cycle input Y1 and Y2. We can see it here. Input is evaluated, and #5 output is evaluated. This Y1 is evaluated, and after a beginning block closes only, and they will be assigned. So #5 and this again this #10. So you can see here in the circuit, for this case, clocks, it is this one. For Y2, it is like a clock delay of #10. #5 and #10. #10 is here it is a delay of #5, and here it is a delay of #10. It's again it's previous to the it's similar to the previous case, which is, and that is shift register with delayed clocks. So we covered up to this. Now we will move on to the next example. Next example is this. Concurrent assignments means always at the rate of positive edge of clock, always at the rate of positive edge of clock. So both will be, there are two always blocks. So we'll move on to this example. So here the thing is, we have to think then that what the value of Y1 would be, because these are concurrently, they are these both blocks are being processed. So Y1, what would be the value of Y1? Because this Y1 is to be assigned to Y2. We will check in the simulation. Concurrent assignment case. We will move on to the next example. This TICL 9. TICL 9 open. TICL 9. Then this. Open this. We've done it. Clock cycle, input, and concurrent assignment means this. Input is assigned to Y1. Input is assigned to Y1. Is assigned to Y1, not Y1. Is assigned to Y1 at positive edge of clock. So this is value of Y1 now. And again means the second block also is there, means always at the rate of positive edge of clock. Y2 is assigned Y1. So this Y2 is assigned the value of Y1. Y1 is this, so Y2 is assigned this. And here it is 0. In all the values are 0, so 0 at Y2 also until the next positive edge of clock. It reached that input was high. So at the next positive edge of clock, it becomes high, and the same Y1 is assigned to this. This covers example number 9. Now we will move on to the next example, which is example number 10. We'll open this project, and it is 9. So we'll move on to sample number 10. Sample number 10 is this. Just updating. Timing 1 and timing 1 TB. The slide, it is in the lecture slides, it is example number this. So slide number 26, it is on slide number 26 here. So what it infers? What it infers is This, it looks similar. Let us check the output. Does it change or not? This, because this y2 is assigned the value of y1 only at the next clock cycle. This that is the next positive edge of clock, because of this non-blocking statements. So we'll check with the simulation. Here it is. Here, input is evaluated, and at the end of that, it is assigned at the positive edge of clock, and then here always at the rate of positive edge of clock, this y1 has to be assigned here, but it is not, means this y1 had not got the value of, and had not been assigned the value of input yet. So there's a y2 will show the previous value only up to here. Only at the next clock, positive edge of clock, will it be, assignment will happen, and this y2 will show the value of y1. So what it does means it is this. The delay is not there. Means at the positive edge of clock only it will show, but this it will be shifted. So it's a shift register without delay. Without delay means as soon as positive edge of clock occurs, it will show the output. As soon as positive edge of clock occurred, it had shown the output for y1 as well. It's a shift register with 0 delays. Now we will move to the next example. There is some delay in the clocks. In this case, as you can see, it's statements are blocking. Means assignment happens. That's why y2 would y1 gets the value of input, and this the same value of y1 will come to y2. But there is this delay in evaluation of this statement. So it is similar to delay in the clock itself, like this. For D, for the first one, D flip-flop, it is like a delay of clock by 5 time units. And for the next one, because assignment also happens, so for the next one, it is like a delay of 10. For the next, because both are both are in different always blocks, means at the rate of positive edge of clock, both are to be evaluated. So both are to be evaluated. Yeah. So for the next D flip-flop also, it's like a delay of 5 only. It's not like delay of 5 for this, delay of 5 for this. So delay of 10 for in the case of second in the case of second flip-flop, no, because this always block has been split. This always block is for this also, and a separate always block is for this. So there is a delay of 5 for both the clocks. For both the flip-flops. So we will run this code. We will run this code like this. We have to find y1. Yeah, we have to move on to the next example. Actually, this one is still the previous example that is shown. So we will open it, TICL 11. Timing 1 and timing 1 TB. Here, there's a test bench. These are the inputs. Concurrent assignment, delayed evaluation. See, at the rate of positive edge of clock, this evaluation is delayed, means hashtag 5, there's a delay in the clock of y1. And again, as this hashtag 5, this delay is also with respect to positive edge of clock only. So it is delay of just 5 time units for execution of this for D in the clock for this D flip-flop, second flip-flop also. If they were in the same positive edge of, if they were in the same always block, were they in the same always block, they would have they were this for this second D flip-flop, it would have been like, it would have created a clock delay of 10 time units. So here it is. We'll run it. Here, input at the rate of positive edge of clock, input is evaluated after 5 time units and assigned to y1, and input is and this y1 is evaluated and assigned after 5 time units with respect to positive edge of clock to y2 as well. Here, with respect to positive edge of clock, 5 time units delay is there, and then y1 is evaluated and assigned to y2. So this is the waveform. Now we will move on to the next example, that is example number 12. Example number 12 is this concurrent assignments. So here at the rate of positive edge of clock, it's similar, but evaluation will happen. Evaluation will happen, but execution assignment is delayed. So there is no statement after it. So it is again similar to the previous case. It's 5 clock cycle delay for this and 5 clock cycle delay for this, because in the always block there is no in this always block there is just one statement. So even if evaluation assignment is delayed, it doesn't matter. Okay, so it is like the previous case only. So output is this. How does it differ? Yeah, it differs. It looks like that, but delayed evaluation, but this output will reflect only with this positive edge of clock is there, and then it will shift it here as this initial for, because this initially the value was not assigned. So here up to here it showed just the previous value of y1. Okay, y2 was just showing the previous value of y1 up to here, because of a non-blocking statement, because assignment happens late there. Okay, so here it is. We'll show that project. Open and TSCL 12. It is not this case. It is still the previous case actually. TSCL 12 is showing this case. It is showing this case. Timing 1. Hashtag 5. Y1 is assigned input, and it is assigned y1 is assigned to y2. There is a delay of 5. There is a delay of 5 time units. Next example is TICL 13. ACL 13. Simulation sources here. Here it is. This. So in the lectures it is here. Y1 with delayed Y1 input, and Y2 with delayed Y1. Y2 with this non-blocking Y1. So we will simulate it here. Here it is. It's like it's a shift register with race condition. Here, this Y1 is equal to input here at the, with a delay of 5, and then this Y1 is assigned. Y1 is assigned means as it is non-blocking. So here it this assignment doesn't had not happened for Y1, so it still showed the previous value of Y1, which was this, and then it got assigned and showed the value shifted the shift register is shifted value here like this. So it's a shift register with a race condition. Thus for this part it was input was not available. Then we will move on to example number 14. 14 is 14. Here it is. 14 is an example of shift register with delay. Shift register with delay. Delay means here the delay is in this D flip-flop. Earlier, it was a delay in clock, means it was responding to the delayed clocks. Here it is delay in assignment. Delay in assignment means there is a delay in the D flip-flop. So how the output is? Shift register with delays and shift register with race conditions. Here it is. this retracer with delays. We'll run it, run simulation. Here we'll go to sources, timing1.v. So timing1.v and timing1.tv, and this is the waveform. So here it is, y1, this assignment is delayed by this time unit. So here assignment is delayed, and this assignment is also delayed. So delay in assignment is equal to means at the rate of positive edge of clock, and assignment got delayed by 5. It is a delay in the D flip-flop. So it is example number 14. Now we will move on to the, I think it is last example. Yeah, it is concurrent assignment. It is the last example. Here instead of this blocking statements, we have non-blocking. Instead of blocking statements, we have non-blocking. So what it does, there is again a delay in the buffered state in the D flip-flop, because hashtag 5 is here, hashtag 5 is here. So we will open it here and PICL 15 timing 1 simulation source, timing 1 TV. We'll run it. Here you can see that always at rate of positive edge of clock. This is non-blocking assignment. This assignment is delayed by 5. Here it is, assignment is delayed by 5, and at the positive edge of clock, this is delayed by 5. Okay, and here as assignment happens late, here we don't have any input, or this means it will retain the previous value of y2, which would have been a value of y1 only, because it is taking input from y1. So up to here it shows the previous values, and then after at the next positive edge of clock, there is a only after 5 time units delay, this value gets assigned to this. So there's a time 5 time units delay here. So it's the same thing, means as shown in the lecture slide. It is shift register with delay. Okay, and delay is in the buffer and in the D flip-flop here. So thus this ends simulation part of demonstration 4, where we demonstrated all the codes that were given in the lecture on timing controls, and this emphasized how the delays at different parts of the statement reflect in the output by either as a delay in the clock or as a delay in the D flip-flop. So thank you.